Every single click, swipe, transaction, sensor reading, it's all generating data. And today, we're unpacking a massive modern challenge. In this explainer, how do businesses manage an absolute ocean of information without, well, drowning in it? Because let's face it, raw data on its own isn't insight, it's just noise. To turn that noise into highly valuable business intelligence, organizations absolutely have to architect scalable data pipelines. So today, we're taking a really close look at the cornerstone technology making this whole thing possible.
It really comes down to this one crucial question. How do businesses survive the avalanche of big data? Just think about this for a second. Humanity generates over 2 quintillion bytes of data every single day. 2 quintillion. That is a literally mind-boggling amount of information. Obviously, we're way past the era of simple spreadsheets here. Organizations are just getting inundated. And if a system isn't scalable, it's going to snap right under the weight of that avalanche.
Okay, let's map out our journey for today. First, we'll look at the big data problem itself. Next, we'll dive into the Hadoop ecosystem. Then, we'll trace the actual 5-step pipeline. And finally, we'll wrap up with some best practices for scaling.
All right, part 1, the big data problem, navigating the avalanche.
Before we can build a solution, we kind of need to understand the monster we're dealing with, right? And that challenge is defined by the 3 V's. First up, volume. Data loads aren't just growing, they're exploding exponentially. Your pipeline absolutely has to handle these massive, constantly increasing loads without slowing down. Second is velocity. We're talking about the sheer speed at which data hits us. You need near real-time processing because waiting days for answers just doesn't cut it anymore. And third, variety. Data doesn't just show up neatly packaged in rows and columns anymore. It's coming in diverse, messy formats from all over the place, which means you need seriously flexible processing strategies.
So, moving on to part 2, the Hadoop ecosystem, the superhero solution.
So how exactly do we conquer those 3 V's? Well, we turn to Hadoop. If you're not fully familiar, Hadoop is an open-source software framework built specifically to store and process massive datasets. And here's the brilliant part. It operates across clusters of standard commodity hardware. You don't need to go out and buy a multi-million-dollar supercomputer. Hadoop scales seamlessly. You can literally start with a single server and scale that up to thousands of machines, all working together like one giant cohesive brain.
Now, what's really interesting here is how Hadoop actually delegates its workload. It uses this highly modular ecosystem. First, you have HDFS, the Hadoop Distributed File System, which gives you that high-throughput storage. Next is MapReduce. This is the engine handling the actual processing using a parallel distributed algorithm. Then we've got Yarn, or yet another resource negotiator. Think of Yarn as the cluster's manager. It's deciding where the compute resources need to go. And finally, Hadoop Common, which is basically the glue, the supporting utilities that help all these modules talk to each other seamlessly.
Let's head into part 3, the 5-step pipeline, a data journey. Okay, let's see how this builds. Now that we have our toolkit, let's actually track a single piece of raw data as it travels through a complete factory pipeline. Here's our 5-step roadmap. 1. Ingestion, catching the data. 2. Storage. 3. Processing the raw info. 4. Transformation, making it useful. And 5. Analysis and visualization, where we actually strike gold.
All right, diving right into step 1, data ingestion. This is absolutely critical because we have to grab this fast-moving info before it completely overwhelms the system. Hadoop handles these high-velocity streams by hooking up with specific ingestion tools. Think Apache Flume and Apache Kafka. These tools act like giant digital funnels. They gracefully catch this incredible fire hose of data and bring it right into the Hadoop ecosystem in a highly structured, organized way.
Once we have caught all that data, we're on to step 2, data storage. It has to be stored reliably, and this is exactly where HDFS steps in as our highly secure digital warehouse. See, instead of trying to shove one massive file onto a single hard drive, HDFS chops it up into smaller, manageable blocks. It then scatters those blocks across the cluster's machines. Why? For fault tolerance and redundancy. If one server totally crashes, it's no big deal. Copies exist elsewhere. It guarantees high throughput and, most importantly, total peace of mind.
With everything safely tucked away, we hit step 3, data processing. This is where the heavy lifting happens. Doing this sequentially would take forever, right? But Hadoop's MapReduce framework uses powerful parallel processing. It deploys dedicated workers across all the cluster nodes to tackle these massive processing jobs simultaneously. And the best part is, it's super versatile. Your team can write these MapReduce jobs in languages they already know, like Java or Python, allowing everyone to work in the environment they're most comfortable with.
Now step 4 is where the real magic happens. Data transformation. And this step brilliantly illustrates the shift. We start with raw, messy data straight from ingestion, stuff that a business user literally cannot read. But by layering on tools built on top of Hadoop, like Apache Hive and Apache Pig, that chaotic noise is instantly converted into beautifully structured, usable data. Hive is especially cool because it actually lets analysts use simple, familiar SQL-like queries to finally make sense of everything.
Which brings us to the final destination, step 5, analysis and visualization. This is the big payoff. With the data all transformed, the wider Hadoop ecosystem jumps in. You want predictive machine learning models? Use Apache Mahout. Need real-time analytics? Apache HBase has you covered. And ultimately, you can pipe these refined insights straight into visualization platforms like Tableau or Power BI. Just like that, a massive, messy avalanche of data has officially become clear, actionable visual insights driving real business decisions.
Moving to our final section, Part 4. Best practices for scaling, the optimization playbook.
So, the crucial point here is that building the pipeline is honestly only half the battle. Maintaining it is the other half. You can't just set it and forget it. To keep this massive setup cost-effective and efficient, you really need to follow a few best practices. First, use Yarn to optimize your resource allocation, so every job gets exactly the compute power it needs, no more, no less. Second, implement data compression in HDFS. It saves storage space and actually speeds up processing. Third, you gotta regularly monitor and tune your performance configurations. And lastly, build in strict checks and validations to keep your data quality flawless from start to finish. To bring it all together, I want you to keep this fundamental truth in mind. Hadoop is a pivotal tool for building data pipelines that are not only scalable, but also efficient and cost-effective. By leaning into this ecosystem, the distributed storage, the parallel processing, the transformation tools, businesses really can tame those 3 V's of big data. Hadoop really is the cornerstone here. It empowers organizations to actually put their data to work instead of just hoarding it.
Which leaves us with one final thought. Data volumes and complexity, they are only going to accelerate from here. The tools exist, but the strategy is entirely up to you. As data continues to grow in complexity and volume, how will your business adapt its pipelines to survive the next big data avalanche? Thank you so much for joining me for this explainer. Keep learning, stay focused, and I'll catch you next time as we continue exploring the complex systems that run our world.